going to have a sharing on multimodality data fusion, a tool for futuristic treatment guidance. This is the topic that I've actually proposed for this session. Right. When we look at, we start with a little bit of definition on diversity. We look at when we look at multimodality, what we are really looking at is diversity is the most important thing. It's the property that allows to enhance the user's benefits and insights in a way that cannot be achieved with a single modality. So also when we look again about modality, what is the real understanding when we say a modality in today's environment is we are looking at number of things. The first thing we are looking at is the type of data that we have. We have text data, we have image data, we have signal data, we have many different type of data. But how can we bring these data together and then make them communicate to each other? I think that is our biggest challenge. So in that case, when we look at data fusion, is the way that the analysis of several data sets such that different data sets can interact and inform each other. So this is one of the main important thing in the hospital environment, in clinical environment of hospital environment. There is different type of signals, image and data being collected for any kind of diagnosis today. So how can we make these different data to speak to each other and make a good decision? That is our main challenge in this. So when we look at what is modality now, again, we are looking at different kind of mode used to capture information or data from an individual object or environment. And we said multimodality is understanding how meaning is constructed from the captured data. So this is we are coming to the very important aspect now, meaning. What we mean by meaning and constructing the captured data into a meaningful information for the doctor to relate it to the patient, for the patient to take it to himself and understand, and they able to go through the treatment or to monitor their progress. So this is the main aspect. It is becoming more important in the what we call it in telehealth. You see, when we come to telehealth, most of this monitoring and also the following up and all that is actually focused on the patient. So patient has to have the understanding and an ability to capture the data and also to use capture the information and to use the information to carry out their needs and their daily needs. So this is actually giving a very big challenge in this industry as an overall. So now how can we use this multimodality technique to actually to cater to this challenge? So we have the physical system, like what we normally have as manufacturing or transportation or anything. So now we have these multimodal data sources. So when we say multimodal data sources, the data can come from sensors. It can be a content data. It can be like history data, or the what has happened in the country in the long run. Now, like we have a pandemic, we have COVID. We want to know what other pandemic has happened in our country and what was the scenario, what was the situation, how the recovery has been done. So these are all the different aspects that comes together in the multimodal data sources. And the most important thing is now the additional is the machine data. For example, now we have the X-ray machine, we have the CT machine, we have the MR machine. How this data is going to come in? So when all these data come into a single data source, now we have a massive and complex data, heterogeneous data, and then imperfect data and multi-stream data. So how can I make these different data talk together? So this is where multimodal data fusion is going to come in to do the action. So here we do enhance. What are the capabilities here? Automated decision, performance assessment, fault detection and isolation, prediction and prevention, and predictive and control optimization. And how do we go about this? How can I enhance the system visibility? How can I reduce the uncertainty? smarter decision, resilient against the disruption. These are mainly the research area we are actually looking at. How can I improve this performance in multimodal data fusion? So the utility of multimodal data fusion across disciplines and with general goals are becoming more and more important today. All right. So moving from that to look at, this is an example I would like to quote, a simple example. They encode messages through displays on AR. How can we use augmented reality to capture the information, or how can we use different sensors to capture the information that we want and we want to use in our decision making. All right. So, why do we need multimodality? That is the big question. Can't we just go ahead what we have now? So this is like we say treatment for all. Why we look at this is improve cancer data for public health, for example. Second example I put here is the access to the early detection and diagnosis, timely and accurate treatment, and supportive and palliative care. So these are the some of the clinical needs currently. With the changing lifestyle type of, for example, palliative. Those days we all, I mean, the we or most of the ladies, they were at home. So someone is sick, someone needs care, and these always been the duty of the housewife or the person who stay at home to do the job. So with that, they we don't need additional support or different type of support that we actually want need today. So what we look at today, we don't have this type of luxury. We don't have anybody at home to care for these patients, and they were, even though they have that, they have a very limited area, they, I mean, time and all those things. So how can we do this, such support and make our parents or our child or our siblings or anyone who needs this type of care feel comfortable, and they don't feel that they are left out and they have nobody to care for them? Because most of the time people who are ill, the recovery is very much dependent how comfortable they are, what are they feeling about the entire treatment process. So this is where this type of system is becoming more and more important for us in day-to-day life. So when we look at multimodality as a form of diversity, here, what is the how do I start this? What is, if I'm a student, I'm a researcher, how do I look at it? What is important to be a multimodality researcher or multimodality knowledge owner? I want to work in this field, and what do I need? The very important, the very first important aspect we look at is the mathematical preliminaries. Yeah, in most applications, researchers are interested in extracting knowledge from data. In real life scenarios, each observation or measurement often consists of contribution from multiple sources, and these can be divided into sources of interest, which carry valuable information, and other sources which do not carry any information of interest. And finally, the latter type of contribution is sometimes referred to as noise or interference, depending on the scenario and the context. Right. So, in when we say in the form, a form of diversity, again, data driven. So, when we wanted to go into the multimodality, my recommendation is always, let's look at this approach: data driven versus model driven versus rule based methods. Because most of us, we are very familiar with the rule based methods. So now, how can I move my rule based methods understanding into model driven or the data driven? So here we have the methods for building, okay, data driven, model based, and rule based. So look, when we look at data driven, is a model of system is built from historical data and used to predict validate data from a system itself. Yeah, so the common techniques here we use is machine learning, artificial neural networks, and support vector machines. So when we move to model based, a model based system is built from first principles and used to validate data from the system itself. Common techniques where we say parity equations, observers, and also common rule based system. We are talking about a set of rules are defined from expert knowledge and used to determine not. So common techniques here is expert systems and pattern classification and limits and alarms. Right. So when we look at these are the three different methods normally we go in modality: data driven, model driven, or rule based. So when we, I have given an example here how a modality in the form of diversity we look at. If you have a cube here and you see that many different cubes or rectangles or different type of sets come in, like we have the metabolites, we have the mass spectra, we have the emission spectra, and then we have the metabolites from different modality which comes together into a single box, and we say linked mode matrix and tensors. Data sets are represent four different acquisition methods here, and all the data sets share the same samples mode. And array in this case is a third order tensor, and maybe is coupled in different modes and also via only one part of mode. So when we put those different data, different modality together, and we are trying to process and we get common compromise to get the information or the decision that we want to make. That is the main beauty of this multimodality data processing. Okay, what are the challenges at a data level here? The first challenge is at the acquisition and the observation level, where the non-commensurability and also different resolutions, incompatibility signs, and alignment and registration. So these are the very common type, and there's a lot of research has been done in this area where we are trying to identify algorithms that can actually help us to overcome these limitations. And we also, the second type of challenges is due to various types of uncertainty. Like we have the external noise, balancing information from the different origins, conflicting, contradicting, and inconsistent data, and also missing values. So this is these type of problems is mainly, it's more, most of the time is physical, and all we can actually control at certain extent, but sometimes we also use signal processing and also imaging techniques to manage these type of issues when we don't have a control over such setup during the data acquisition. Right. So the next here we are looking at other challenges is of the level of data fusion, linking within the data sets, analytical framework, structured data fusion, a general mathematical framework, and validation. So we actually this is practically the flow. So when we have a certain type of data, we link between the data sets and then we establish the analytical framework. Once we have an analytical framework ready, then we will go into the structured data fusion, a general mathematic framework, and then we validate that. So when we say level of data fusion, we are true fusion using high level features, of true fusion using multivariate features. So we have, and also true fusion using data as is or with minimal reduction. So we have three different type of approach that we can do in managing the level of data fusion. And the last one is order selection and also the dimension reduction. So when we said we are in the right order and the right dimension, this way the data will make more sense to what we want to use them for. When linking between the data sets, we have hard links between the data sets or the soft link between the data sets. When we say hard link, we are physically linked. And when we say soft link, we will do pre-processing and then establish a link between them. Yeah. Next, we are moving into analytical framework. What we mean here by analytical framework is the certain data fusion approaches rely on existing theoretical analytical frameworks that only original been devised for a non-fusion application, at least not explicitly, such as ICA and also algebraic-based methods. And also we use the methods like parafact, generalized eigenvalue decomposition, and so on. One very common, which is widely used now, is regression. Regression provides another solution to data fusion. Regression reaches for latent factors and the best explain the covariance between the two sets of observation. See, when we talk about regression, regression has got a huge area that we can cover. We have linear regression, we have multiple regression, we have logistic regression. So we actually choose the type of regression methods to use. It depends on what type of data we have, what type of application, and also what we are really looking at as an outcome. So all this is going to contribute heavily on the data management, selection of the regression methods. Right. So moving from that to the structured data, a general mathematical model, this is where a model of individual data set is established, and link between the data sets will be established, and loss or objective function, regularization, and the penalty terms, and also the missing values going to be managed. So practically in this section, most of the time we will use a lot of statistics techniques, and to establish the tight mathematical framework from the data that we had. Okay, from there, finally, we'll do a validation of the model that being established. And despite accumulating empirical evidence of the benefits of data fusion, there is still a very little theoretical validation and quantitative measure of its gain. So, choosing an appropriate model here is very important. And it's a widely open question, and approximate and highly simplified models are often preferred, and therefore a validation step is always indispensable. So we how we going to select our validation is again depends on what outcome we are expecting, what is the organization that we work with expect in terms of the model validation. It also plays a big role in our validation process. Okay, finally, I'm going to share a, a project or a product. This is actually already in the pre-commercialization stage. Digital Malay language audio cognitive wellness trainer. So this is a project started in 2012. We started with very fundamental work where we are looking at establishing Malay language based trainer for elderly group, where they can use these. They are not here. They can still hear, but they have some limitation because of the aging factors. They have normally we have a middle ear impairment, where we may not be able to hear people when they speak from the back or from the side of us. This is a project done started in 2012, and now it is a commercial at a pre-commercial stage. So how does brain respond to hearing lost? So from the diagram that you can look here, this is actually practically a cloud-based system that we are using to train people, elderly people, in the Malay language, for them to be able to have a better hearing impact. And we are looking at people who are above 65 years old. So what happened in this project from the day one? We actually, this is a kind of summary how the background to the research that produced this product. So we looked at first hearing loss effects about 2 million over people age of 70, making it one of the most chronic health condition in older adults. So all the statistics, all those information, and everything else is collected in for us to make a design of the framework based on the real need of the patients in the train. So that the training need to be very effective. How we going to make the training effective to people in this, because there's a lot of training system being used in this country, which is Malay, all English language based, and we realize that patients, after going through many time of those system, they are actually not improving their hearing at all. So what actually really happens that they this has come to a big question to us. So we did kind of a lot of data collections, and then talking to people, screening them, take upon their audio signals, and then even we went to the extent of we did CT scan of the all those people who really have this type of hearing impairment, and we accumulate this data together and identify what is the real challenge for them actually to be trained. So this is the second project in this scope is a cloud-based recognition of epileptic discharge. This is a CREED. Okay, CREED is another system that we are actually using to do to assist the medical doctors in a clinical environment, where when you see what happened in seizure or epilepsy, when the patient come to the hospital for their checkup or their follow up and so on, the event doesn't happen that time. So even a doctor do a recording during the clinical visit, they may not know the state of the severity of the epilepsy of that patient. So in our system here, we have a home-based simple device that patients actually can rent from the hospital. Hospital can rent it or loan it to them, and they do the recording at home while sleeping and all those things. And this data is uploaded to the cloud. By the time the patient come to the hospital, okay, so Crete is actually now the data is uploaded, and doctors actually have an access to the right data. The where they can see actually the seizure event take place and all that. For example, the patient can do recording twice a week or every 2 weeks once before they come and see the doctor for the follow up. So this is a type of system. Normally, we work on a multimodality data fusion related. So we have the EEG recording, the unit, and then the patient app, which actually push the data into the cloud, and doctors actually can view, and the processing can be done in a very what we call it. It's not a rush at all. So the doctors have the right report for them to discuss with the family members or the patient themselves. So this is the kind of assistance that again you can see a cloud architecture here, which has been established based on the different type of data. Right. Okay. And we also have this another project on the telehealth services for highway users, which we have a different kind of approach. I taken my medication, electronic pill dispensers and smartwatches and electronic bottles and all different biomonitoring drugs, So what we try to when people in traveling, are they how can they be assist on any medical emergencies they have and so on. So we are trying to accumulate, bring together different technology, different things together to put things in place, and so we can actually get um, the highway users to get the medical help while they're traveling. So here we said, I want to track my own health and that of loved ones, that like maybe their parents are traveling or their children are traveling. They can actually also look into their conditions, and so maybe they are sick but they need to travel on their own. So these are all the concepts that we are taking in here. We want to prevent and control infections, and we get to scene of the emergency faster. If there is a need, a sudden help need, how can we manage this, and can we develop a predictive life-saving approach, and also a nation or effective public health policy, which is very important for people. Especially I never thought when we did this project, of course we didn't have this COVID-19 pandemic, but we really feel this is pretty helpful at this point of time. So this is the how those model framework established for this project, and and these other services, type of services. And here we have the rest area, RNR we call it. So where the assisted community health corner has been established, and we also have the on-site emergency services in this project. Okay, and finally, the last one here is on the home-based personalized finger grip rehabilitation monitoring for the post-stroke patient. where we look at how can a post-stroke patient, because post-stroke patient normally they have a lot of challenges to come for only 20 minutes or half an hour rehab to the hospital. So how can we assist them by being home? That was the real approach. Great assistant to the providing assistance to the patient to do the exercise at home, but at the same time we want the doctors to the rehab personnel to really know these patients have done it right and done it the way they are. So here we actually have developed a framework how this is going to happen. And this is a electronics based product which is still in our laboratory. We still are working on this to be fully we are targeting to 2022 to have a device where the patients actually can wear in their hand. And this particular exercise is all pinching, where the fine-tuned finger movement to be captured. So in these are the examples of the many different type of a project that we can actually park under this multimodality data fusion, compared to the most of the time when we today talk about multimodality or data fusion, everybody is concentrating in a particular area where data science and everybody has an impression that these projects are actually all based on data alone. So it is not really and many people have asked me, what's going to happen to all those other career if the computer science is only type of knowledge is required. But which is not true. That's a lot of other knowledge is required before we come to that data science decision making and doing the predictive activity. We have many layer at the back that we need to prepare for any kind of project in this sector.